Okay, now so we have done 3 in the previous class. Now go to 4, case 4. Okay, case 4 is, now we're bringing it, as we said in the beginning, closer and closer. So now at C means next will be between C and F, right? Between C and F. Object placed, case number 4. Object placed between C and F. Okay. Okay, let us draw. You know now by now how to draw the concave mirror. Facing left, reflecting surface facing left. Mark your C and then take 4 centimeter. Draw your concave mirror P, half of 4 to the mark F. Okay. Now here object is between C and F. So between C and F you place an object medium size, properly between, exactly between, no need, but properly between C and F. Then you will get a good diagram. Okay. What I mean is if you place it too close to F or C, then it will be difficult to get the diagram. So place that top of the object, bottom of the object. So this is our object. Okay, now from the top of the object you draw a ray, incident ray parallel to the principal axis. This is the incident ray. Okay, now you know the rule, this ray will reflect and go to the focus, so let it go through that. Okay, so mark the direction, right to left, opposite to the incident ray, which is from left to right, arrow left to right. Reflected ray therefore must be right to left, right? Now we need 2 rays, so pass it through the focus. As you pass it through the focus, let it strike the mirror here. So incident ray passing through focus, we know becomes parallel to the principal axis. So draw a line that is parallel to the principal axis, like this. So these 2 reflected rays, 1 and 2, meet here. So that's where the image is formed. So draw your image there. And mark this one will be the top of the image, because these are coming from the top of the object. So this will also be the top of the image, right? A dash, B dash, and this is your image. Okay. Now, where is the position of the image? When the object is between C and F, image is formed beyond C, right? So formed, let us write here, formed beyond C, comma, still in front or left side of the concave mirror. And it is real and inverted, means we need a screen to receive it. We won't see it behind the mirror like you stand in front of your looking glass. You see behind that's virtual, that's why it's behind. But every real inverted image is in front. So we need a screen, and we cannot see virtual images like your home mirror. We can see directly behind the mirror. We don't need a screen. But every real inverted image needs a screen to be seen or received. Okay. So real and inverted. And then size of the image is taller than object. So you write here, image is magnified. Okay, magnified. So from case 1 to 4, so far we've seen every image formed by the concave mirror is real and inverted and in front or left of the concave. So we now know that every real inverted image is formed always in front or left of the concave mirror, and every virtual image is formed behind the mirror. Example, the image formed in a home mirror that is always behind, that is virtual, right? Okay, so case 5. Let's go to case 5. Then object is now between F and C. Next will be at F, right? So object placed at F. You write down at F. Okay. Let's draw a ray diagram. We know now by now how to draw C. And then for this case, okay, so you just draw 4 centimeter again. Mark your pole and halfway through F. Okay. Then exactly at F you draw your object. Medium size is enough. Top of the object, bottom of the object. So this is your object. Okay, draw it. Oh, we need 2 rays, right? So from the top of the object, you draw a ray parallel to the principal axis. First one, incident ray, left to right. So after striking mirror, this ray will always go to focus, so pass it through the focus. So this is the direction, right to left, opposite to incident ray. Opposite direction to incident ray. For the second ray, this is a new rule we're going to introduce, okay? So between C and on exactly at C and A, place your scale, okay, that ruler, and draw it up to the mirror. And let me explain to you after that. Like this. Okay, 9. Then, okay, finished now. Okay, then from top of the, this is how it is traveling. From top of the object, it will move from left to right. So this is the direction of incident ray. Okay, draw that. Then because this ray is coming in the same line with C, the rule is like this. It will bounce back through the same path of the incident ray. Reflected ray, incident ray path are same when they come from the same straight line with C or when it comes from C, okay? And then the reflected ray will continue to travel like this and go like this. 1 reflected ray, 3 I've drawn. Actually 2 is enough if you want, okay? So once you're through with that, then let us write here. Image is formed here. Then now you will see if you drew properly, then the two reflected rays are parallel to each other and moving left side. See arrow moving left side. So it'll parallel means they will meet at infinity, means very far away from the mirror. So the image will be formed because the rays will intersect at very far distance, infinity, formed at infinity. Okay, formed at infinity. But still, they are traveling to the left, so it will still be on the left, so it will be in front or left of the concave mirror. And they will really meet at infinity, so it will be real and inverted. And the size of the image will be so huge that you will have to call it as highly magnified. So if someone were to go at infinity and place a white sheet of cloth, big one, you'll see a huge image, right? Something like my thumb size or candle, small candle object, the candle will become so huge on the screen, okay? That's why it's called highly magnified. So now remember this, every real inverted image from case 1 to 5, every image was real and inverted, and they were in front or left side of the concave mirror. This is important to know for numerical, that's why I'm repeating. Every virtual erect image is from behind the mirror. Example, your home mirror, very easy, no need of screen. Directly can be seen behind the mirror. But every real inverted image cannot be seen directly. It has to be seen by putting a screen. And it is always from on the left or in front of the mirror, okay? So that is what. And one more case is there, so let us go there. Case 6. Case 6. So remember, every image real inverted on the left. Object is placed between, now at F, so between F and P, or P and F. You can say F and P or P and F. Write it down. Let's draw the mirror again. You just draw it here, and then mark your C. And this time, for case 6, please remember this also in exam. We need space in front, so draw now, take 6 centimeters from your scale, because we need space, because it's going to be between P here and halfway here. F means we need some space in front to draw the rays, so that's why take 6 and divide into half 3. At 3 you mark the F, okay? Case 6. Now that is a suggestion because that's convenient distance. Mark the non-reflecting surface. So since the object is now between F and P, properly between F and P, you mark a small object. Don't make it too tall. Smaller the better, because it will go out of your paper if you draw it too tall. Okay, object should be small here, because you're going to get a magnified image. So let me just say this is object. Okay, now this is the top of the object A and bottom of the object B. Let us say A and B. Okay, we need 2 rays. From the top of the object, you draw a ray parallel to the principal axis. And left to right it travels and hits the mirror. And it will bounce back, reflect, and go to focus. So we know the rule now. So it'll go to focus. So So let it go to the focus like this. So this is the direction of the reflected ray. Look at the arrow. Now we need two rays, right? For the next one, you put your scale at C and A. Like this, you put it at C and A. Then draw full line up to the mirror. Don't move your scale on the same straight line. Continue to draw backwards. More and more. Okay, we'll need some space behind the mirror now. So same straight line with this one you have drawn on the left side. On the right side, you draw right side of the mirror, you draw broken lines like this. Sufficiently long so that you don't have to go back again. Okay. Now we know the rule for this. A ray coming from the same line with C, from the stop it starts first. This is an incident ray. After hitting mirror, it will bounce back along the same path and continue to travel like this in the left direction. So reflected ray 1 and 2, both are traveling to the left. But you will notice they are diverging, means going more and more away. So they are never going to meet each other on the left. So image will not be formed in the left, on the left in this case. So they cannot meet on the left because they are divergent. See, look at the arrow pointing left. They'll go like this, right? More and more away, so they'll never meet. So only if you produce backside, then they will meet, because the rays are divergent. So produce the next one, same straight line with the reflected ray here, and draw broken rays. Continue to draw till it cut the first one you have drawn just now. See, they have cut here for me. Because they're divergent, they cannot really actually meet. So we make them look as if they're meeting. They are not meeting. Now this is a virtual point, sorry. So draw your line longer so that you can draw that image there, okay? So this is where they meet for me, so I draw here the image. Okay, so here, both of these are being produced from the reflected rays coming from the top of object. So this also will be the top of the image, A dash and B dash. So this is your image, so you can write it down. Okay, write it down. Okay, now, if you have a good look at it, this is the only case where the image is formed on the right side behind. Previous 5 cases were really inverted on the left. So this is different type of image. So let us write the thing here. Image is, position is formed behind. For the first time we are seeing it behind. And behind means we also call it as right side. Behind or right side of the concave mirror. Okay, behind the concave mirror. Okay. Then how about the nature? Look here now. These two rays are not formed by real rays. They are formed by broken rays, means virtual rays, apparent rays. So it will be called virtual image. This is not a real image. So our definition for real image was images formed by actual or real intersection of reflected rays. But virtual image definition is images formed by intersection of virtual or apparent rays. Means rays which look as if they are meeting, but they are actually not meeting. That's the sense, okay, technical sense. Virtual and erect. Erect because up is up, see A up, A dash up, right? And it is bigger than the object, so it will be magnified. So this is the only case where the image is virtual, erect, and the position is behind or right side of the concave mirror, right? So now let me show that to you. So when you put your object very close to the mirror between P and F, you always get an image behind the mirror, virtual, erect, and magnified means bigger. This is the concave mirror. Now my thumb is between P and F, okay? Now I'll put it on the camera screen. You can see the thumb size, or you can rather hold a pencil, will show it clearly, okay? Okay, so maybe a pen, you know this pen size here, real one, as you can see from the camera. Now look at the image from behind. Isn't it bigger than this one? The image, and then it is behind, right? You don't need a screen, you can see actually directly behind. See? See, much bigger, because this object is between P and F. So the one I'm showing here on the camera right now is the exact case of this one, okay, on the board. Okay, I hope you got it. The other cases, when you put, you won't be able to see the image behind, because every one of them is real inverted in front. But this is the only case when you can see big one magnified behind the mirror, virtually erect, and behind the mirror. No need of screen directly, because this is virtually erect. Images do not need a screen. Okay. Now finally here, so we have learned today this. This is very important for numericals. So write down. Remember. Okay. Write down along with me. Remember two things we have learned: real inverted image. What did we learn today? Always formed where? In front or left of mirror or concave mirror. We saw that with our own eyes, so it should not be difficult to remember, okay? Because we need this for numerical. 2, we saw here virtual erect image, as we showed just now here. Always from behind, or it is always on the right side of the mirror. You can simply say mirror or concave mirror. Okay, so finally, remember this point. And finally, one more point. So remember this: concave mirror is the mirror which can form real inverted in front of it, or it can also form virtually erect like this behind it. So this mirror can form both types of images: virtually erect behind the mirror or real inverted in front of the mirror. So if a question is asked saying what is that mirror which can form both virtually erect and real inverted image, that's your answer: concave mirror, right? Okay, that completes this portion. Okay.